Okay, so some quadratic equation, second degree polynomial kind of thinking. So some things we like to be able to write back and forth between standard form and vertex form. Honestly, vertex form is a little more important to work with. It tells us a lot more information. And basically what happens with this is, and you probably remember this from other classes, earlier classes. Okay, if I have a parabola, the vertex is one turning point. If you think back to that week, section 1 work, 3.1 work, where if this is a second degree equation, there's only going to be one turning point. That means there's only one vertex. We don't usually talk about vertices for a higher degree. The turning points of vertices, they could be, but I mean, it's not really, we don't usually do it that way. So the vertex, generally what we'll do is we'll think of the coordinates of the vertex being in the form hk. So hk is the vertex of any parabola. And what we'll do is here's the general form for that. And so that is where the vertex is. Remember, we change the sign because the general form is minus h. So if it were written, if this were, suppose this parabola is over here, I'll have it open down, and that vertex is -3, 1, and we'll assume the stretch factor is just 1, so we'll write y equals x plus 3 squared plus 1. And if it were over here, where this was 3 and this was 1, we'd write that as y equals x minus 3 squared plus 1 plus 1. Because the general form says minus h, and if h happens to be a positive number, it's x minus, and if h happens to be a negative number, if the x coordinate of the vertex happens to be a negative number, we change the sign. So you always look at this number and change the sign for the x coordinate. The y coordinate stays the same, but that's just an up-down shift, a vertical translation. If they give us the equation in standard form, we could complete the square. You might have learned that in an earlier course. Honestly, though, the easiest way to do that, and I know if you watch some videos, they'll show you that. Honestly, the easiest way to do this is use this little shortcut formula. And it's part of the quadratic formula. You probably recognize that. You just take the b number, negative b over 2a. So if they had written it out, I don't know, I'm going to make this up. Y equals 3x squared plus 6x minus 5. And I had to find the vertex of that. To find the vertex, I'll do negative b over 2a. So -6 over 2 times 3. Well, that works out to be -6 over 6, so -1. So I know the coordinate for that one would be -1 for the x coordinate. Then to find the y coordinate, what you're doing is you're going to find f of -1. So we go back to the function and square -1. So that's 1 times 3 is 3. So for this one here that I made up, this would be 3. I'm going to do some examples like this in a minute here, but I'll do it just to give you one. And then 6 times -1 is -6 minus 5. What is that? -11 plus 3 is -8. So this vertex would be -1 common -8. And that's how you do it. So here, let me do some cleaning up here. So vertex is -b over 2a for the x, and then we'll find f of -b over 2a for the y. And that's basically how you find that. The vertical intercept is going to be 0 and then c. If c is if the equation has a c term, that's what it'll be. An example that something's not like that. If I have x squared minus 3x plus nothing, well, c is going to be 0. So the y-intercept, the vertical intercept, the y-intercept would be 0, 0, the origin. Okay, and So same deal here. So the vertical intercept would be, I guess we'll do the same thing. We'll have to do, I would do, to make this easy, I would just find f of 0, drop 0 into that equation. I wouldn't try to do some kind of fancy formula here. To find the horizontal intercepts, we'll do 0 equals f of x, or f of x equals 0. And then you go to factor it, use a quadratic formula or whatever, you know. And this is the same. Okay, so here y is equal to 0. And here x is equal to 0. Okay, so I guess that's the start. Let's go do some problems. Number one mistake that pre-calculus students make, Algebra 2 college algebra students make, is this. They'll see x minus 3 squared, and they'll treat that as x squared plus 9. Okay, they're treating it like it's a distributive property situation. So don't do that. I'll roll my eyes. You won't see me roll my eyes, but I'll roll my eyes. What you want to think about it is x minus 3 times x minus 3. Then, of course, we have the negative 2 out in front and the minus 36. Then what we got to do is we got to do some distributive property, or foiling if you want. So x times x is x squared. We have a minus 3x and another minus 3x is minus 6x. Negative 3 times negative 3 is positive 9. And then we'll distribute the 2 through. 2x squared minus 12x plus 18. And then we're going to combine like terms. So 2x squared minus 12x minus 18 will be that function in standard form. Now, if we want to write it in vertex form, this is where we're going to do, well, one thing I would do negative b over 2a. Do that x equals negative b over 2a we talked about on the first slide here. So negative 4 over 2 times 2, that gives me negative 1. And then I'm going to evaluate f of negative 1. So that's 2 times negative 1 squared. Right? 2 times negative 1 squared is positive, so it's 2. 4 times negative 1 is negative 4, plus another negative 4, so what is that? Negative 6. Okay, and I see the leading coefficient is 2, so I'm going to write 2x plus 6 squared. Remember how we changed this x plus 1 squared? I don't believe we did that. Sorry about that. At least I caught myself before I went too far. So x plus 1, because that's the x coordinate, squared, and then minus 6. So that is this in vertex form, because I can see the vertex is negative 1, negative 6. So that the x goes there, the y goes there, and then the leading coefficient is 2. That's a stretch factor. So here's an equation. I see a vertex right there. That vertex is 1, 2. So I know it's going to be x minus 1 squared plus 2. Then I get to decide if there's some kind of stretch factor. Well, for one thing, I know it's the leading coefficient is going to be negative because it opens down. But normally with quadratics, right, if you think about a table of values, if I start with a vertex, let's see, what if we do negative 1, we're going to do 0, we're going to do 1, we'll do 2, we'll do 3. X. Don't have to make this table of values, folks. I'm doing this so you can see what's happening. Y. If x equals 1, y is negative 2. We can see that right off the graph. If x equals 0, y is 1. If x equals 1, y is 2. If x equals 2, we're back down to 1, and then we're back down to 3. Here's the vertex. When I go left of the vertex, the function goes down 1, over left 1, down 1, right 1, down 1. And see that? So that's the same. It's going from 2 down to 1, or it's going from 2 down to 1. If I go back 2, so if I come over 2, this function is decreasing by 4. It's that squaring factor. So this function hasn't been stretched at all. It's still going over 1, down 1, over 2, down 4. It would be going over 3, down 9, because it's got the squaring going on. So the only thing we have to worry about is make sure that it opens down by sticking a negative in front of it. And that is the function. I mean, I could write y or f of x. This is a 2, not a 3. Kind of looks like a 3. Okay, so there's that one. For this function, I'm seeing a vertex of 4, 1. I know it opens up. I also know, though, I remember how the last one went over 1, down 1? Well, this one, if it were not stretched, it would be over 1, up 1. But if this is going over 1, up 2, it's going over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So this is a vertical stretch by a factor of 2. So y equals, or f of x equals 2. There's the vertical stretch. It's positive because it opens up. X minus 4, you take the x coordinate and drop it into the formula, squared, don't forget the squared, and then plus 1, not minus 1. So there's the graph of that function. Or there's an equation for that function. Now this one, what did they tell us? They told us, they didn't tell us the graph. We could graph it. It wouldn't be wrong to do that, but it'd be nice. This will get you ready for section 3 where we have polynomials, and I mean, it would be a pain to graph everything. I know this. I see a vertex. I know that it's going to be y equals some stretch factor maybe times x plus 4 squared plus 3. And now I know it contains this point xy, so let's just drop it in. -1 equals I don't know times -2 plus 4 squared plus 3. Now we'll just solve this for a. Subtract 2, so -4 equals a, and that's going to be -2 plus 2 is 2. -2 plus 4 is 2. Square it, we get 4. So won't a equal -1? So this parabola opens down and it's got a stretch factor. So we're just going to change this a to be -1. I could just stick a negative in front of it. I don't even need to do the -1. Okay, so that's how you can find an equation of a parabola when you don't know the graph, when you're just giving you some features. Okay, so there's a couple of ways to do this. I do know this. I know it's y equals a times x plus 2, because that's one of the zeros, times x minus 6, so that's the other 0. Now I just need to do the stretch factor. I mean, I could expand this all out and then substitute in. I know c would have to be 6, but I don't have it in that form, and I don't really want to do all that work. So what I can do at this point is I can say 6 equals I don't know times 2, because x is 0, right? Times -6, sorry. -6, because I'm dropping in 0 for x in both those cases. So doesn't 6 equals a times -12? So if I divide by -12, 6 divided by -12 is -1/2. So I'm going to replace that a with -1/2. And it doesn't say write it in standard form. It doesn't say write it in vertex form. So we'll just leave it like that. I mean, we could, if we had to write that in vertex form, maybe I should do that for you. Nope, just a minute here. So some things we can do. We could expand this all out. Then we can do the x equals -b over 2a trick like we did. You also can think about, hey, I know this parabola crosses the x-axis at -2. I know it crosses it at 6. And I know it opens down and sets some kind of stretch factor going on. I also know the vertex is going to be halfway between those two numbers. They're halfway between those two zeros. So if this is a distance of 8, half of that is 4. So if I jump up, let's see, 1, 2, 3, 4. So what is that? That's at 3. And if I add 4 more, oh, it can't be at 3. Must be at 2. Must be at 2, and I can't add or subtract. That's exactly what happened. I can't add or subtract. So that would be at 2. So because -2 is is 4 places to the left, and positive 6 is 4 places to the right. So I know it's going to be negative 1/2 times x minus 2 squared. And then what's the vertex going to be? Well, if I could drop in, I guess I can come back up here. And let's evaluate this function for x equals 2. So that's going to be, let's see, x2 plus 2 is 4, and 2 minus 6 is negative 4, and the negatives cancel, and 16 divided by 2 will be 8. So that'd be a one way to come up with a vertex fairly easily without doing a lot of work. 8 seems high to me right now if I'm looking at my graph. Let's see. If x equals 2, right, I said it was 2. 2 was right, so that's going to be 4 and negative 4. No, I think that's right. I think I'm okay. All right, so that's one way to do it. All this problem, as I said, though, all this problem is asking you to do is write that, and I'm happy if you can do that. And then we're into the exercises, and you should probably try these. Doing these exercises will give you some work on paper to use, and it'll make the MyOpa math go a lot more quickly. This one's pretty interesting to do. And you can go look at the answers in your they worked out answers, so you can do it. I don't think I need to do it in this video. Give a yell if you want me to.